Today's video is the second video in my series where I migrate my home network to run entirely on MikroTik hardware. In the previous episode, we migrated from my OpenSense router to a MikroTik RB5009 and it's been working flawlessly. So now in this episode, we'll be migrating from my existing Cisco business switches to a set of MikroTik switches. But first, I'd like to thank MS Dist for sponsoring this video by providing all the hardware you see here. MS Dist is an official distributor and reseller for MikroTik and other brands including Ubiquiti and Teltonika. They offer competitive pricing, including special pricing for trade customers, have received great customer reviews, and have product experts available if you need an extra hand picking the right product or after sales support. So, if you're interested in buying any of the hardware you see in this video, or any other networking hardware for that matter, definitely check them out, and I'll leave links to all the products shown in this video along with a discount code for MS Dist in the video description and in a pinned comment. So first up, let's run through what I currently have in terms of switches along with my requirements. Currently, I have 3 separate switches in my main comms rack. A 24-port gigabit non-PoE switch, which is used for the vast majority of devices, a 12-port 5 gigabit PoE switch, which is used for devices that either need multi-gigabit speeds or PoE, and a 12-port 10 gigabit non-PoE switch, which is used for devices that need 10 gigabit. But this switch doesn't support multi-gigabit speeds such as 2.5 and 5 gigabit Ethernet, it only supports 10 gig or 1 gig. I originally bought these switches when I was in my flat, and now that I've moved, this mix of switches isn't really ideal. For example, most of the ports of my nice 5 gigabit PoE switch are connected to 100 meg PoE devices such as cameras and Dante audio interfaces. In terms of my requirements nowadays, for the vast majority of devices, I just need a ton of gigabit PoE ports to handle everything from TVs to CCTV cameras to smart home devices and everything in between. Then for higher speed devices, I want a decent number of 10 gigabit ports for connecting things like servers and workstations, and since I'll be running this over Cat6a cabling running through the building, I need a 10 gig base T switch rather than something that uses SFP+ modules. Now while it would be nice to have multi-gig PoE ports for future high-speed Wi-Fi access points, this isn't something that MikroTik currently offer, so we'll stick with non-PoE 10 gig ports for now, but if MikroTik ever release any sort of multi-gig PoE switch in the future, I'll definitely be taking a look at it. And then based on those requirements, here we have the switches I've gone for. So let's jump in closer and take a look at each of them. So first up, here we have the switch that will sit at the core of everything, and it's the MikroTik CRS 354-48P-4S Plus 2Q Plus RM. And this thing is a bit of a monster. On the front of the switch, we can see we have a total of 48 gigabit PoE Plus ports with a total PoE power budget of 700 watts. So that's going to be absolutely way more than enough ports for basically all my gigabit devices, both PoE and non-PoE. Then next to that is where things get really interesting. We have 4 10 gigabit SFP+ ports, which I can use for interconnecting all my switches or to connect servers at 10 gigabit speeds. Currently most of my servers use 10 gig base T interfaces since that's what my old switch has, but I could eventually move them over to SFP+ next to free up copper ports and also slightly reduce the power consumption. So all fairly standard so far for a high-end switch, but then it gets really interesting with a pair of 40 gigabit QSFP+ ports. So with these you could either chain a bunch of these switches together at 40 gigabit or connect them to other 40 gigabit devices, but that's not something I'm really going to have a use for. However, what's really cool with QSFP+ ports is that they're essentially 4 SFP+ ports combined into a single connector. This means that with an appropriate breakout cable, you can actually split this out into 4 10 gigabit SFP+ connections. MikroTik sell a DAC cable that breaks out to 4 SFP+ connectors, but you can also get ones that break out to things like LC fiber connections. In fact, if you look closely at these QSFP+ connections, you can see that there's a bunch of different LEDs under here. We have these arrow-shaped ones at the end, and these represent the QSFP+ connection full 40 gigabit connection on both the top and bottom ports. But then we also have these 8 smaller LEDs in the middle, and each of these represents a single SFP+ connection on one of the 2 QSFP+ ports. So with this switch, if you factor in the ability to be able to break these QSFP+ connections out into separate SFP+ connections, this switch basically has a total of 12 10 gigabit interfaces, which is brilliant. And now getting away from all the excitement of the super fast ports, we then have the final 2 ports, which is an RJ45 serial console port and a 100 megabit Ethernet port, which you can configure as a dedicated management port. These management ports are great for situations where you accidentally mess up the VLAN config and lose access to the switch. You could either configure these with an IP address and then connect them to some sort of management network, or what I like to do is set up the switch to run a DHCP server on this interface. That way I can simply plug a laptop into this port and get a connection to the switch. Then as for the rest of the switch, we have a bunch of linking activity LEDs for all the ports, and then above them we have these windows that contain arrow-shaped LEDs that indicate the PoE state of the ports below them. They aren't the best looking things in the world since the light does tend to bleed between adjacent LEDs, but they do work. The only other thing that's worth mentioning on the front of the switch is the ordering of the ports. MikroTik do it a bit differently to other brands, so the numbers start from 1 in the bottom left and then count up from there, so 1, 2, 3, 4, 5, 6 and so on. Of course, this isn't an issue, but it's just something to bear in mind. If you use switches, for example, where the numbering starts in the top left hand corner and then counts from there, it can be pretty easy to get mixed up. Then around the back of the switch, we have the AC power inlet, and it also has this nice little clip to help hold the cable in place. Then cooling wise, the switch does have a bunch of fans, and it's definitely not silent, but it's not too bad. You definitely wouldn't want this sitting in a room with you, but it's also not the sort of thing you'd hear screaming through walls. As long as you're planning on keeping it in a comms rack like I am, you'll be fine. Then next up we have the switch that I'll be using for higher speed connections, and for that I've gone for the MikroTik CRS 312-4C Plus 8XG-RM, and this is one of the best value 10 gigabit switches on the market. On the front of the switch we can see we have a total of 12 10 gigabit ports. These are RJ45 ports, and these also support 2.5 and 5 gigabit speeds. Then next to that we have 4 10 gigabit SFP Plus ports. As you can see, these are labelled as combo ports, so this just means that you can either use these as an SFP Plus port or an RJ45 port, but not both at the same time. So for my setup here, I can uplink this to the other switch using a 10 gigabit SFP Plus DAC cable, and then have a total of 11 10 gigabit base T connections to connect to various devices around the house. Then as before, we have an RJ45 serial console port, a 100 megabit Ethernet port for management, a bunch of status LEDs, and a USB port which you could technically use to connect to some sort of mass storage device or a USB mobile data dongle, but you're probably not going to be doing that unless you have a really weird use case. However, what is possibly useful with this is that with this USB port you can reset the power state of it from within RouterOS. So if you have some sort of device that supports USB power that you want to be able to reboot remotely, you could technically do that with this port. Then, taking a look around the back of the switch, we can see we have a pair of redundant PSUs. Now of course these aren't hot swappable, but they could still be nice for situations where you're feeding the switch from a pair of redundant power feeds. However, it's also completely happy if you only plug one of these in, so you don't need to use both of them if you don't want to. Then like before, the switch is actively cooled. It's not super loud, but again, you probably wouldn't want this sitting right next to you. Then the final switch we'll be installing today is the CRS 310-HG Plus 2S Plus IN, and this switch will be going in my living room AV cabinet, just to provide enough switch ports for all devices in there. And this is a really neat little switch. We have a total of 8 2.5 gig ports, and then a pair of 10 gigabit SFP Plus ports, which is really impressive for such a small switch like this, especially since it costs under £200. We then have a USB port like the previous switch, and a DC input for the external power adapter. Around the back of the switch, we can see that it does have an active cooling fan, and while it definitely screams at full speed, it quickly ramps down, so I'm hoping it won't be an issue having this in the living room. Then in terms of form factor, as you can see, it's a nice little desktop switch with rubber feet on the bottom, but then it also has a couple of mounting holes if you wanted to mount it somewhere. Or you can also rack mount it using the included rack ears, which I have here. So they're one big long ear, one short ear. You'd put them onto either edge of the switch, so like that, and that would let you mount it in a 1U rack space. And of course you could put the ears on either side to mount it whichever side of the rack you really want it on. So yeah, it would kind of look like that if it was rack mounted. Then with the optional RMK 2/10 rack mount kit, you can either mount 2 switches of this form factor into a single 1U space side by side, or you can mount this switch into one of those 10-inch mini racks that a lot of people are getting into nowadays. So there you go, that's the switches we're going to be using. But if you look closely, you might see that the CRS 312 has the words Cloud Router Switch on it, and that's what CRS stands for in the model number of each of these switches. So what on earth does that mean? Well, MikroTik's naming can sometimes be a bit weird, but you'll find that their switches are generally divided into 2 ranges: the Cloud Router Switch or CRS range, and the Cloud Smart Switch or CSS range. And the main difference is in terms of the operating system that they run and the overall functionality. These CRS switches run the full RouterOS operating system, which technically means that you can use these switches as routers and run firewalls, NAT, BGP and all that sort of stuff on them, but we'll go into that more in a second because that wouldn't really be the best idea. On the other hand, the CSS range run a different operating system called SwitchOS, which is much simpler. It's web managed only, it doesn't really have any layer 3 functionality, but it still gives you all the functionality you'd expect from some sort of smart switch, such as VLANs, LACP, port mirroring, spanning tree, and so on. It's also a lot easier to use than RouterOS, and in fact, some of the CRS switches can optionally be set to boot into SwitchOS if you prefer that to RouterOS. So just bear that in mind if you're buying MikroTik switches. If you're going for one of the SwitchOS models, just make sure that SwitchOS has all the functionality that you require. But what about RouterOS, and using the massive amount of RouterOS functionality on these switches? Well, here we have our old friend, the block diagram that we talked about in my previous video. And in particular, we're currently looking at the diagram for the CRS 354. What you can see here is that all the network interfaces are connected into this single switch chip, meaning that all switching can happen at full wire speed. Then off the side here, we have this little 650 MHz CPU, which itself is connected to the switch chip over a 1 gigabit link. And this CPU is what runs RouterOS. This means that while you technically can use all the features of RouterOS on this switch, most of them will be running on this tiny little CPU that maxes out at routing maybe about 500 megabit. Now, this could still be useful. For example, if you're installing the switch in a remote site and you wanted the switch itself to be able to make a VPN connection into a remote management network, you definitely could do that. Or maybe you wanted to run something lightweight like a DHCP server on the switch, that would be fine. But you definitely wouldn't want the CPU to be doing any real heavy lifting. Then looking at the CRS 312, it's very much the same thing. Switch chip and then the same CPU over a 1 gigabit link. Then on the CRS 310, it's similar again. This time the CPU and switch chip are part of the same physical chip, but once again you still have a small CPU linked to the switching hardware, this time over a 1.3 gigabit connection. But surely with this you can still use some of the advanced features of these switches without being constrained by the CPU? And yeah, you can. You just need to know what you're doing. The way it works is that you get blanket access to all of the RouterOS features, which by default run on the CPU. But then some of these features support layer 3 hardware offloading, where you'll configure the features in RouterOS, but RouterOS will then offload the processing onto the switch chip. And with those features offloaded, you can then use them at full speed, much like any other layer 3 switch. MikroTik have this page that explains which features can be offloaded, how to enable offloading, along with any potential limitations. Different switches also have different limitations in terms of how many routes and fast track connections they support, so you can also check out this if you're planning on using these as layer 3 switches. And that's the main thing with RouterOS switches. They can be super powerful and they can be used as proper layer 3 switches, but you just need to be careful since it's very easy to accidentally enable a feature that isn't offloaded to the switch chip, causing all traffic through the switch to be forwarded to the CPU and then absolutely tank the performance. It's not like most switches where you'll only be presented with features that the switch chip is capable of. With MikroTik switches, you get access to all of the features of RouterOS, and it's left up to you to work within the limitations of the hardware. It's also worth mentioning that the term cloud in the various names of MikroTik products doesn't mean these have any sort of cloud management or anything like that. These are very much locally managed devices, and the term cloud is really nothing more than a buzzword that MikroTik started using long before cloud managed network hardware was a thing. The final thing I want to quickly talk about is using VLANs with these switches. Because unlike most switches, these switches don't have VLAN filtering enabled out of the box, so there's a little bit of configuration you need to do before you can use VLANs. It's all documented here on this basic VLAN switching page, but you'll notice that there's two different ways to do it. One for the modern CRS 300, CRS 500 and a bunch of other devices, and then there's another set of instructions for older CRS 100 and CRS 200 devices. Taking a quick look at the process, it's not too painful once you've got your head around the MikroTik way of thinking. We create a bridge interface and then add all the switch ports to it. Within each of the switch ports, we then specify the frame type to either accept VLAN tag traffic if we're using it as a trunked port, to accept untagged traffic if we're using it as an access port, or we can also set it to accept both tagged and untagged traffic if we're using it as a hybrid port. We can then specify the untagged VLAN ID within each port. Then in the VLAN section, we define each of our VLANs, and this is where we specify the tagged ports. So it's a little bit weird in the way that you specify the tagged ports under each VLAN, but then the untagged VLAN ID under each port, but once you get your head around that, it's completely fine. Then finally what we're doing here is we're creating a layer 3 interface within RouterOS for the management VLAN, and then assigning an IP address to it, and that's how we'll access the switch's management on a particular VLAN. Then up until this point here, we've configured all the VLANs, but the switch would be ignoring them. So what we finally need to do is enable VLAN filtering on the bridge, which will cause VLAN functionality to spring into life and work much like any other managed switch. Then for older switches we have different configuration down here, which I'm not going to go into in full detail. It's a bit different in that you almost explicitly sort of define how you want to add and strip VLAN tags from packets as they move through the switch. It's a bit different, but these are older switches, you're unlikely to really need to use this. Essentially, if you're thinking about getting one of these switches, I strongly recommend checking out videos from MikroTik along with other channels such as the Network Berg, which go into full depth into how to configure these switches for VLANs. But once it's all configured, it's not too scary. Here in Winbox we can go to Bridge and then Ports, and this will show us all of the switch ports. Within each of these we can come in, we can add a comment, we can configure spanning tree, we can configure the VLAN IDs, and then down here we can set the frame type, which as we mentioned before is similar to how on other switches you configure a port as an access port or a trunk port. It's just a bit differently worded here. Then if we go back out of here and come into VLANs, here we can see the VLANs. And within each of these we can define the VLAN ID, the name, and then we can define which ports are tagged ports for that VLAN. There's also an option in here to add untagged ports, but this is redundant since you would need to define the untagged VLAN ID under each port, and that will automatically populate this list whenever the interface comes up. So that was a look at the VLAN and the switching config. Then on top of that, there's some additional config under the interfaces section, which once again will give us a list of all the switch ports, and inside each of these, we can configure things such as the MTU, link rates, PoE, and then also view the traffic stats. You'll see in here as well that I've added comments to some of these ports just to describe what is connected to them. However, unfortunately, these comments only apply to this interfaces section. If I wanted those comments to show up under bridge ports as well, I would need to manually add them over here too. So I'm not going to sit here and say this is the most thoughtfully laid out interface ever for a switch. It's not. It's very much the classic MikroTik thing of it being a router operating system made to run on switch hardware, meaning that the configuration areas that are important for a switch are kind of spread throughout the interface. It might take you a few hours to get your head around it at first, but once you figure it out, it's still completely usable. Then there's only one more feature I want to quickly mention because it slightly confused me at first, and it's RouterOS's Detect Internet feature. If this is enabled, RouterOS will look for interfaces that are connected to some sort of internet connection, and if it finds one, it will do things like start a DHCP client and add routes. This can be useful, but if you were to do what I've done and set up a management VLAN and assign a static IP address to the switch, if this feature is still enabled, the switch will still also try and get an IP address over DHCP on all of its interfaces. So just remember to disable this if you're not wanting to use it. It's not like other switches when you set a static IP address it will usually disable DHCP. With RouterOS you need to explicitly disable the Detect Internet feature. Finally, in terms of power consumption, with no interfaces connected, the CRS 310 draws around 11.5 watts, the CRS 312 draws around 18.5 watts, and the CRS 354 draws around 51 watts. So all fairly typical for modern switches. It's not like buying old enterprise switches that absolutely eat power. It's maybe a little bit higher than expected on the CRS 354, but part of that is probably because it has such a powerful PSU to handle all the PoE output that at idle it's not going to be operating at its most efficient. Of course, power consumption will also slightly increase for every device you add, probably around half a watt or so for a gigabit device, 1 to 2 watts for a 2.5 gig device, and maybe up to say 3 watts for a 10 gig device. So that was a look at the switches. Now let's run down to the garage and get these installed. So now here I have my existing setup where I have a set of 3 patch panels that connect to all the structured cabling that runs around the house. Then there's patch leads from this that pass through these brush plates and then pop out of these cable management finger bars and run into the switches. Additionally, cables to other devices within the rack, such as servers, also pass through the back of these finger bars and plug into the switches. Then, as we saw previously, we have my 3 existing switches that I'll be swapping out for the 2 new MikroTik models. I'll maybe need to play about with the layout a little bit, but my thinking for now is to install the 2 switches with one of these finger bars in between. I can then bring the cables through the finger bar and either run them up or down into the desired switch. This should look pretty neat and it'll make it very easy to move cables between the switches. Now, some people might already be starting to write angry comments saying that I should just put the switches between my patch panels, alternating between switches and patch panels, and then neatly patch each switch directly into its neighbouring patch panel. And this is a valid way of laying out a rack, but it's not the only way to lay out a rack, and it only works in certain situations. Now, where it can work is in large commercial installs where you can install a bunch of identical switches, patch every single run into a switch, and then it gives you the benefit of being able to manage everything remotely. You'll never need to go in and move a patch cable, you can just configure the port in the switch config. However, doing this has a few disadvantages. First of all, it means that you need to have at least as many switch ports as you have network drops. And generally speaking, it's common to run many more network cables than you actually need, so that you have room for future expansion or to work around faulty runs. This means that you can end up needing to pay for significantly more switch ports than you actually need. The second disadvantage is the main reason I'm not doing it here, and that is because I have a range of different types of switch ports for different devices. With my old setup here, I have 1 gigabit non-PoE switch, one 10 gigabit non-PoE switch, and a 5 gigabit PoE switch. And I then patch the different runs into whichever switch has the correct type of port for what I'm connecting. Similarly with the new switches, one of them is gigabit PoE and the other is 10 gigabit non-PoE. Most devices will be connected to the gigabit PoE switch, but then some devices that need higher speeds will be connected to the 10 gigabit switch. If I were to do what people bang on about and exclusively alternate between switches and patch panels, you'd then need to ensure that every switch port meets the highest requirement that any network run could require. In my case, 10 gigabit and PoE. Of course, you could then patch between switches and non-neighbouring patch panels, but then this gets messy and completely defeats the point of organising the rack in this way. Finally, with my rack here, these switches also need to connect to devices within the rack itself, not just the patch panels. So for that, I can just pass the cables directly through the finger bars to the back of the rack and plug them into the servers. I'm not personally a big fan of where people use keystone couplers in patch panels purely to pass cables between the front and back of a rack. It just feels like a lot of unnecessary points of failure for purely aesthetic gains. So with my setup here, the only things on the patch panel are network runs that leave the rack and run around the house. So with that out of the way, I'll now go away off camera and get the switches installed. So there we have it. That's the switches now installed and working, and they work absolutely fine. As you can see, most of the devices are connected to the gigabit PoE switch, and some of the ports have the PoE LEDs lit. And this is where you can kind of see the bleed through I was talking about a little bit, where, for example here, only one of these ports is actually using PoE, but you can kind of see the LEDs either side have a bit of the light bleeding through. It's not the best looking thing in the world, but they do work. What I've also done here is I've tried to keep the cables that go to the patch panels over to the left hand side of each switch, and the cables over to the right hand side of each switch run to devices within the rack, and it just keeps things somewhat organised. In terms of organisation, when I bought these patch leads back when I was in my flat, I had a bit of a colour coding scheme going on, along with having each cable serially numbered on each end to help match up the ends of the cable. Of course, since then, I've run out of cables with the correct numbers and didn't want to get around to labelling others, so the system's completely gone out the window. But I think at some point I'll go away and order a bunch more correctly coloured patch leads and try tidying this up again. The final thing I want to quickly look back to is the power consumption. Because whereas previously we just took a look at the idle power consumption of each of the switches, what I also did is before I installed the new switches, I measured the total power consumption of my old switches while connected to all the devices including PoE devices, and then when I put in the new switches I measured the power consumption once again of the switches in their fully up and running state. With my 3 old Cisco business switches, I was drawing round about 110 watts from the wall. With these 2 new MikroTik switches, I'm now drawing round about 100 watts from the wall. And both of these figures include about 27 watts of total PoE power. So yeah, the power consumption is round about the same as my old switches, saving 10 watts, which is nice. I've lost a few multi-gigabit ports, so some of the 5 gig ports I've lost, but I've gained an absolute ton of gigabit PoE ports, which are definitely more useful, and 10 watt saving is quite a nice little bonus. Power consumption wise, these switches are really basically average. They're not super ultra low power switches, but equally they're nowhere close to some of the higher end enterprise switches that can draw hundreds of watts at idle. 100 watts for all the switching, including 27 watts of PoE, is something I'm completely happy with. And then here in the living room we have that small switch in my AV cabinet. This is currently uplinked to the rack over a 2.5 gigabit connection, which is entirely because I can, since nothing here really requires it. I could have used one of the SFP Plus connections to connect it at 10 gigabit, but that would have just been silly and just a waste of an SFP Plus module. But yeah, that's it in here and working. The fan isn't too loud, although it's definitely slightly audible in a completely silent room. I'd probably say it's about equivalent volume to maybe being in a room with a slightly loudly ticking clock. I'll see how I feel about it long term, and I may end up swapping out the fan for a silent one if it becomes an issue. So there you have it. That was a look at migrating my home network over to MikroTik switches, and so far they're working really well. The software side of things is definitely a bit different, and it does take some getting used to, but now they're all up and running, they work fine, and then doing ongoing configuration tweaks and things like that are really pretty easy to do when I'm used to it. So yeah, hopefully you found this video interesting or potentially useful if you're considering MikroTik switches, and stand by for future videos where we take a look at the access points and then finally take a look at my completed setup up and running and talk about my experience. But all left to say now is thank you very much for watching, and if you're interested in buying any of the hardware shown in this video, definitely check out the links to them on MS Store in the video description.